Section 7.4, Properties of Logarithms. The objective today is to use properties of logarithms. Here are your 3 properties that we're going to practice in all of our practice problems today. For any positive numbers m, n, and b, where b can't equal 1, the following properties apply. The product property, log base b of m times n is the same as log base b of m plus log base b of n. So mainly when you start off on the right side and you see 2 numbers that have the same bases and you're adding them, you can multiply their parts. The quotient property, if you have 2 numbers with the same base that you are subtracting, you can divide their parts. When you have a power property, you're looking for a power to a power, and what happens is you can take the exponent and move it down in the front. So basically that's what's shown on the right side. How do we use these? What is each expression written as a single logarithm? So here, notice we have 2 logarithms, base 4. We need to actually simplify until we only have one of those. And it's as simple as we can make it. So the first thing I notice on this one is that we are subtracting 2 logs. So we're going to use the quotient property on this one. So we're going to write it as 1, log base 4, and we're going to divide their parts. 32 divided by 2. So that becomes log base 4 of 16. Now, when you're thinking about this one, you're thinking, what can I factor 16 down as so that it has the same base number? So of course 16 is 4 times 4. So I'm going to rewrite 16 as log base 4 of 4 squared. The goal is to get this number and this base number to be the same. Because when that happens, the log base 4 of 4 basically cancels itself and you just get the number in that exponent spot, which is 2. The next one. The first thing that I notice is that we are adding these logarithms. So we're going to use the product property first. Actually, no, let's go like this. The first thing I'm noticing here is the 6. I want to change that. Before we can do anything with it, we have to get it out from the front. We're going to do the same thing with that 5. So it becomes the exponent. So the first property we're going to use is the power property. Oops, power. So once we do that, it'll look like this. Log base 2x to the 6th plus log base 2y to the 5. Now we're going to use the product property. And that says if you have two logs with the same bases that you are adding, you can multiply the parts. So log base 2 x to the 6 times y to the 5. And here is all that we can do. Got it? Question number 1. You guys can pause the video, practice each one of these questions. On the first one, there's no numbers in the front, so I'm not going to do that. The first thing that I notice is the addition symbol. We're going to use the product property. Log base 4, oops, that's disappearing. I'm not sure what's going on here. Okay, so log base 4, 5x times 3x. becomes log base 4, 15x to the 2. I cannot rewrite 15 as 4 to a power. I cannot write x squared as 4 to a power. So we are done. The next one, what I notice is there's the number in the front. So that's going to become the exponent. So we're going to use the power property. Log base 4 of 6 squared minus log base 4 of 9. The next thing I notice is we're subtracting, so I'm going to use the quotient property. Log base 4 of 36, that's 6 squared is reduced. We're going to divide those parts using that quotient property, and it becomes log base 4 of 4 to the first. The reason I put that 1 there is because anytime your base and the base of the number match, the whole thing cancels, and you just get whatever that exponent is. So this one simplifies all the way down to 1. Problem number 2, what is each logarithm expanded? On this first one, notice that there is no base. I'm not really super concerned with that. I do notice that it's division, so I'm going to use the quotient property. So log 4x minus log y. Notice that there are 2 terms here, and those 2 terms are multiplied. So I'm going to use the product property now. Excuse me. It's a product, so I'm going to, anytime you have 2 things that are multiplied, you add logs together. So it's log of 4 plus log of x minus log of y. And that's the most that we can expand this one. The next one, log base 9 x to the 4 divided by 729. So the first thing I notice this time is the division symbol. So I'm going to subtract the parts. I cannot do anything necessarily with the x part, but I do notice that there's an exponent, so I'm going to drop that down in front. So it's 4 log base 9 of x. Now I'm going to rewrite 729. I want that to become a little smaller, so I'm going to see if there's 9s in there, since 9 is the base. 729 is 81 times 9. 81 is 9 times 9, so this whole thing would be a 9 to the 3rd. And remember, anytime those bases match, you just get the number that's left. We can't do anything else with that first term, so I'm going to leave it like it is. You guys can pause the video and practice got it questions number 2 and check to see if you got them right. On the first one, we have a division symbol, so we want to take care of that first. Log base 3, 250 minus log base 3 of 37. 250, I'm going to do a little factor tree here, would be 25 times 10, which would be 5 squared, 5 times 5. And then 2 times 5. So it becomes log base 3 of 5 to the 3rd times 2. 37 is a prime number, so I'm going to leave that one the way it is. Notice that this is a product, so I'm going to use the product property this time. Log base 3 of 5 cubed. Oops, I'm going to run out of space. Log base 3 of 5 cubed plus log base 3 of 2. Those can be in any order. Minus log base 3 of 37. Now, the only thing I need to take care of is this exponent comes down in the front. So 3 log base 3 of 5 plus log base 3 of 2. Excuse me again. Log base 3 of 37. That's all you can do. So how do you know when you're done with these? You cannot have anything with an exponent. You can't have anything with a quotient or a division symbol. You can't have anything with a product. If all of those things are gone, then you're done. So the next one, notice that there's a product here, even though it's not written. I also see an exponent, so we have to take care of both of those things. I'm going to take care of the product first. So log base 3 of 9 plus log base 3 of x to the 5. Log base 3 of 9 is not simplified because 9 can be written as 3 to a power. So log base 3 of 3 squared plus log base 3 of x to the 5. There's two exponents here. This first one, though, the base and the base of the number are the same, so this one becomes a 2. But this one I do want to bring down in the front because there's a variable left. So 2 plus 5 log base 3 of x. No products in that little part following the word log. There's no exponents and there's no quotients either. Now, what do you do if the numbers don't really have any relationship necessarily with each other? You use the change of base formula. So for any positive numbers m, b, and c, b cannot equal 1 and c cannot equal 1, you are going to change it to a whole different base. A lot of times that base is 10, but it doesn't always have to be. And then you can divide those numbers. Notice this one goes on the top, this one goes on the bottom. So it's the big number divided by the base. So what's the value of this expression? I'm going to do B first. For this one, 5 and 36 really have no relationship to each other. So I'm going to rewrite these with a base of 10. Remember, our calculators are in base of 10. That's why we want to change it most often to base 10. So log base 10 of 36. Remember, the number goes on the top, the base of the log goes on the bottom. So log base 10 of 5. And then you're going to grab your calculators and you're going to divide those two. Remember that when you put this in your calculator, it will actually have a parenthesis here. Enclose it before you divide. It'll have another parenthesis there. This one you don't have to enclose, but the one in the middle is very important that you do close that. On your calculator, you're going to get about a value of 2.23. Now let's go back and do log 81 and 27. Those numbers are a little bit bigger. So what I'm going to look at is if I do a factor tree of each one of those, 27 I already know is 3 cubed. 81 would be 9 times 9, which is 3 to the 4th. So they do have a relationship to each other. My pen's not working again. So I'm going to rewrite these as log and this one was a 4. This one's going to be written as log base 3 of 27, since they both have 3's in them, divided by log base 3 of 81. Remember, the base number is on the top, the base of the log is on the bottom. So log base 3 of 3 cubed divided by log base 3 of 3 to the 4th. Remember, those cancel, and you get 3/4. Now that's kind of the long route. Here's the calculator one, and we just kind of went over that a little bit ago. So on the calculator, to check this one out, it would be log base 10 of 27 divided by log base 10 of 81. So if you divide those numbers, you get 0.75, which again is 3/4. Go ahead and pause the video and you can practice your got it question number 3s. The first one you can change to base 2's. The second one, they don't really have any relationship to each other. So on the first one, It'll be log of 32 divided by log 8. 32 is 2 to the 5th. So I'm going to change this to base 2. Log 2 to the 5th divided by log 2 cubed. Those will simplify and you get 5 over 3. Now, if you use your calculator to simplify, this will be log base 10 of 32 divided by log base 10 of 8. And you get 1.67, which is 5 over 3. The second one, like I said, they don't really have a lot of relationship to each other. So we're going to take log base 10 of 18, or log of 18, divide by log base 10 of 4, or just log of 4. And the number that you get is 2.085. And that is it. Come with questions tomorrow as we work on the assignment in class.